Hi, I'm Philipp. I wanted to talk a bit about Open Policy Agent, just to get a general feeling. Who has used OPA before? Okay, who has heard of it before? Okay, since this is more of an intro talk, you're probably in the right place. So let's see, I'll start a bit with the motivation and why and how, and then we'll get there. So I'm Philipp, I work for Elastic, the company behind Elasticsearch, Kibana, Beats, Logstash. We have also started to work a bit more in the OPA area just to gain security insights and then feed that back into our products, but I can show you a bit more about that at the end. And I'm the famous or infamous developer advocate at Elastic who travels most in Europe. Like I think it's the third time I'm here, so I do a lot of conferences and try to show what we're up to. So let's dive into what we can do. I have a bit of an ops background, and what I've been doing in the past was often something like this. So I was using Ansible to configure my services or servers. And here then I have a role that basically said at the end I would check, are any of the ports that I don't want to have exposed, are they exposed and open? So did I open port 22 and 25, for example, and then my rule would shout and tell me like, you have opened something that you probably didn't mean to. Check if that is really what you want. Maybe you have done something similar in the past as well, that you have part of your deployments, you have some sanity checks or quick security checks to see if everything is in the place where it should be. But this has a couple of downsides. Or as in security, most of the people are always saying like, this is fine until it is not anymore. And we'll come to the not fine part later on. So what you generally want is, you often want to decouple that policy change control from your application. So you don't only want to check like something is in the right state as you deploy it, but you want to kind of like continuously check that, like every hour or so you check that nobody manually changed something and opened a port that you didn't mean to, not just when you deploy it. So you want to decouple that security policy from the change management probably. You also want to run those policies constantly so that somebody just debugged something and opened a port, for example, doesn't catch you weeks later and nobody has noticed. So you want to constantly run these checks to figure out you're still in the state that you expect, otherwise you might be caught off guard later on. Or you want to manage those all as code and probably somewhere explicitly and not part of like 1,000 lines of deployment scripts, because it's very hard to keep track of what were the security checks, what were general changes, and do I have everything in place that I want to have where it needs to be. GitOps is the thing that everybody throws around, but it's really something where you have like audited, these are the policies or rules that I want to have in place to make sure that my system is as secure as I want it to be or configured the way I want it to be. And you probably want to gain insights into the policy state all the time so that you can have a script checking and saying like, out of the 100 rules that you have configured, 90 are passing, and these are the 10 that are not passing right now. And then you can figure out why are they not passing, and is it a big deal? Do you need to fix that right away, or is it just like some minor thing that can wait and you will fix later on? And then the final thing that everybody loves and hates is compliance and audit. But for compliance and audit, you're then often forced to do weird stuff or check random things in your systems. And it would be so much nicer if you would write these policies in general. And then if you have an audit or you need to show how things are working, that you can just show up or pull up those existing rules and say like, yes, we've always been checking this. This is in the state where it should be. And that you don't need to reinvent that as you have an audit coming up. So the general idea of OPA is that you constantly have these policies in place, and that you can always say, this is the state where I am, where I want to be. So I hope this kind of like covered the why. And it's also because there's this saying that security incidents come in these three categories, that FYI, WTF, and oh my God. And oh my God has happened far too often in the last few years, and that was, I don't know, who has been rotating passwords over Christmas because of LastPass? Or was it just us? Or at least we had a company policy that since we are using LastPass, that everybody has to rotate stuff. And I know a lot of people spent the end of December and beginning of January on that, and then we had Log4Shell a while ago. So there are a lot of these pretty high-profile security issues that come back to us, and we should be doing a better job to figure out how they are not happening or what is happening. And I always group them into multiple buckets of how to figure out how bad something is. So the worst case is that you learn that something happened to your system from the press when you make the news, and that's the last place where you want to be. Slightly better, but still expensive, is if somebody took over your hardware and started mining Bitcoin on your cloud instances, which is totally inefficient, but since it's your money, you can do it. That's just expensive, but still not what you want. Or you just see it on the cloud provider's bill because somebody used whatever resources you had lying around. You can prove it yourself after the fact, and you know what happened. That's okay-ish. But ideally, you can prove yourself that, yes, there was a security issue or a breach, but no harm was done because we caught it in time. And the ideal state, and that is what kind of like where we want to get with OPA, is you find the security hole or the misconfiguration before somebody else can exploit it, because you have these security rules that are constantly running, and then you're faster than any attacker to find what is misconfigured ideally in your system. So you know what's happening and what's wrong before anybody else can. And that's kind of the idea of OPA, that it runs before anybody else can get to it. And maybe you tie it into your pull requests, that you run the policies against the pull requests and the changes they would do. So even before you deploy it, you would figure out what is wrong. Or at least you run it every X on your production instances and see in what state they are and where you want to be. And the other thing that often security is very much a tribal knowledge thing, that Bob or Alice know how your things should be configured and they will maybe manually do the tests. The problem is if Bob or Alice are on holiday or they leave the company, that tribal knowledge is leaving with them. So you don't want just to really rely on people having some knowledge in their head and knowing how things should work and what should be allowed and what shouldn't be allowed. But you want to have that codified somewhere. And again, that is where the policies in Open Policy Agent come in, that you want to have that codified knowledge and not just tribal knowledge in people's heads. And this ideally avoids that state where you say everything is on fire and everything is horrible and what the hell is my problem. So this is the security state we want to avoid by having a proper setup and filtering out things that are not right. So this has kind of like hopefully set the stage. So how do we get there? Obviously, there are no silver bullets. Unless you're a vendor, because vendors will always sell you silver bullets. But that only, I think there is this saying that while you cannot buy the magic solution, somebody will try to sell it to you. But for security, unfortunately, it is the same thing. You cannot just buy security, but it's a combination of many factors and things. And OPA is one of the many tools in your tool belt that can get you to that place. It started in 2016, so it's one of the kind of like older CNCF projects. It's one of the CNCF graduate projects by now. When I say CNCF, everybody knows what I'm talking about. The Cloud Native Foundation, where Kubernetes and many other projects are homed by now. OPA is one of the projects there, and it's pretty widely used by Netflix, Cloudflare, and others. And when I say graduation projects, right now there are 20 CNCF graduation projects. Like the first one and most widely known one is Kubernetes. Probably Prometheus, Helm, or some of the others are also widely known and used. Some others are probably more obscure. I don't know, these three, for example, I don't think I've ever used, and I couldn't tell you what they're doing from the top of my head. But they're graduate projects, including OPA. So this has been around for a while. It also has 7,000 stars something on GitHub. So it's one of the more widely used and known projects in there amongst many other graduate projects. And what OPA is generally trying to do, or their approach, is that today everything is basically an API, and they can run policies against APIs. And that could be a Kubernetes API. That could also be you have a host, or maybe you have somewhere SSH running, and you can test your policies against those things that are exposed. You can also check what is happening in containers, or maybe you would even access a UI. But in the end, everything ties back to an API, and that is what OPA will test against. So that's kind of like the modern way to build systems is through APIs, and they mostly go against these APIs. And how that works is you have a service that wants to know in what state are we. It queries OPA. OPA then relies on policies, which are written in Rego. This is more of a Java conference. This is kind of like a complicated statement, but the OPA people say that Rego is like JavaScript, so it's easy to read and write. And we can discuss if that is now true or not. But depending on where you're from, this is true or very false. But this is where Rego is coming from. So Rego is JavaScript inspired, and this is how you can write your policies. You can also add some extra data. And I'll come to an example where you need to tie in extra data. For example, if you have like a relationship, or if you need extra information to validate your policies against. So a service queries OPA, which relies on those policies and that extra data, and then it gets a policy decision back. OPA is not taking any actions or doing anything directly. It's really just you're querying it and it gives you something back. And that something back, bless you, could be true or false, if like this is allowed or this is not allowed. It could also be a more complex data set. So it could get you back, I don't know, an array of values or paths that you can access or whatever. So OPA is really just this evaluation, like a service asks, like, is this thing allowed or in the right place? You run it and you get the answer back. And you can either do that more on a check the system every hour or every 6 hours or whatever, if it's in the right state. There are also some places that run that, like for every API request, they actually validate the API request is valid against OPA rules. So both of those are possible. So what that looks like, and I hope this is large enough. No, this is not large enough. But I'll just show you the source. I'll make this larger. Since my slides are only marked down, we can just easily see that here. So what I do here is, basically we want to have a policy, read your own data. And the policy that is now Rego says, allow this rule if the method is get, and I'm using the path my data, and then attach the employee ID, so it's like test.com my data or /my data / and then the employee ID. And if the user that is actually accessing this, they should have the permission to read that data. And that will give you back true, and that is the state that you want it to be in. So the input that you run this against is like the method that this is running against is get, it's my data, and it's going against the path my data and Philipp, and the user who is initiating that is also Philipp. And then the policy sees that these two employee IDs match, and then your policy passes. So this is what you can express in Rego, basically. You can also make this a bit more complicated if you say, by default, nobody should be allowed to read your data except in this other case here. So the default is allow false. It's only allowed true when this condition is met, so that these two employee IDs match. And then, for example, here, if I say Peter is trying to access the Philipp data, then this would be evaluated to false because the two don't match. So that is kind of like the idea behind Rego. I said before that there is also data that you can use in Rego. That could be, for example, if you want to read your employees' data. So everybody on your team, you should be able to read their data. Then you somewhere need to store who is on my team to then tie that back into the rule. And so you have data that is generally be kept then in memory, where you say the manager of, so Philipp is the manager of Peter, and Kelly is the manager of Philipp, for example. And what you would then have is you do that same rule that you get the employee ID, but then you say the data manager of, so you access data, and then it's this attribute manager of, and then you basically need to have this relationship that it passes through again. So you have both the rule, and you can then have this extra data if you need additional backing information to make the decision in your rule if this is actually should be enforced and makes sense. And that is really what Rego is trying to do and about. Everybody clear so far, or any questions? Cool. Let me switch back to my slides, which are hopefully more readable again here. But you've seen all of that was in the slides as well. It was just a bit small here. To make this a bit more complicated, or maybe real life, if you want to use Kubernetes, they have, or Rego has packages, or OPA has packages where you say, I want to access the Kubernetes admissions, and I'm importing future keywords. So here what I'm saying is, if the resource I'm querying is a pod, then I say the container image needs to start with elastic.co/whatever. So it needs to come from our custom container registry, which is at elastic.co. Otherwise, it would say, like, this image is from an untrusted container registry, and it would fail the test again. So you can query pretty much anything that Kubernetes exposes in its API. You can then put into a Rego rule, and then you could alert against that. You could also do, for example, you have some tags are missing or some labels are missing on your pods, or whatever else you want to check. You can query the API, get the information, and then have that information, like, you're in that correct state or you're not in that correct state. Like all your pods are coming from a known instance or from a known registry. You can also make it a bit more complex. Like here we have an authorization package, and then we have, again, this allow rule that is false by default. Anything that starts with a hashtag is a comment. So it's kind of JavaScript, but also not quite. And then you say, allow if the method is put and somebody uses the pet ID, and the owner of that pet has that pet ID as the ownership, and only then would it pass. So that is kind of similar to the previous example that you could only access your own directory. Here, only the pet owner can change their pet's data. So you could have either something very generic or very common against, like the Kubernetes API, which will be widely shareable, or you can have something very application specific, like here, where you can really encode how authorization should work in your application. And one of the examples I've seen, or that is widely used, is that if you have, for example, a microservice architecture, and then from the outside, there are a lot of things that any user from the outside should not be able to access directly or see. So for example, the S3 bucket that stores the underlying data should not be directly accessible. But even your own developers might not have permissions to see everything. So for example, your developers should be able to debug a lot of things in your system, but maybe they shouldn't be able to access the credit card information you have stored for that user. And only the user should be allowed to change their own credit card information, and only one specific microservice should be allowed to access the credit card information, because only that is doing the billing. But no other part of your system, either because it was misconfigured, or somebody broke into it, or somebody inserted some malicious code, can access some code that it shouldn't be allowed to. So all of that, depending on how much effort you put into it, you could do with OPA. That you can say, like, this type of data can only be accessed by this system or this user or this user group. All of that can be encoded in OPA. Obviously, you need to set up all of these rules to make that work. And for some data, like credit card information, it might make sense. For others, it might be a bit of an overkill. One example that I found nice that has been published is by DoorDash. They check every pull request they have with OPA. If they introduce some change with that pull request that is not within their policies. So what that looks like is, you create a pull request, then Atlantis is their own thing, I think, to work the pull request through and test them. So they have this Atlantis thing that fetches their OPA policies, then executes the OPA policy, and then the OPA policy says true or false, basically. And based on that, they will then allow the pull request to be merged or not. And once that's merged, then you will use that deployment Atlantis tool again, and then you can actually only roll out the change. But it's part of the pull request approval, is that one of the four, they have 4 checks, 3 were successful, 1 was pending. And here you can see OPA failed because it it did something on SSH, like SSH was unrestricted, and they have an OPA policy that says like you can only open SSH if you have an IP restriction attached to that. But any infrastructure change here would be tested with OPA and say like, okay, you're moving to another valid state, and only then can you merge the pull request if you have set it up. So that is what you can do here. The other thing that I think is very nice in OPA is that it has a playground where you can just try out stuff, which looks like this, but I want this tab. Is that large enough? No, this is not large enough for you to read. Is this kind of large enough for you to read? I cannot go much larger. So what I'm doing here is I'm using Kubernetes labels. So you have a couple of examples, but I'm using this one because I think this is kind of nice. I'm saying what you want to do is every resource that you have needs to have a label called cost center. And cost centers have the code C code, cost center code, I assume, dash whatever. And otherwise, it fails with you don't have the cost center code label correctly. And then this is the Rego rule. Here, this input, this is what you get from the Kubernetes API, which can tell you this is the object, and it has the label cost center fake code. And then you have images, but these don't make a difference here. You have cost center fake code. If you evaluate that, it will say this is an unsafe code because it's not properly set. And then you would say fix that by saying cost center needs to have cost center code, I don't know, 1, 2, 3. And if you evaluate that again, then it should work, unless I mistyped. Cost center, CC code, 1, 2, 3. This has worked earlier. Give me a second. This is the rule I want. C code is the rule that I want. And for some reason, this one resists. But you get the general idea. You require the label. There needs to be a label cost center, and then it needs to match, and then it works. For whatever reason, this doesn't work right now. Okay. Anyway, if you try it out yourself, it should work. It worked for me earlier. Whatever I screwed up here. So. How do you deploy this? You can either deploy it as a Go library in your own application, or you can use it as a daemon, though that daemon should ideally be co-located because otherwise you have this overhead from the network. So what that looks like is, and this is again super small, but this here says this is your Go code, and you have the OPA library as a library in your Go binary combined. So your application can constantly check against your OPA rules within the application. Or here, this is a Kubernetes example, where within one pod as a sidecar, you have the OPA container, and your application container can check against the sidecar the OPA rules if they make sense. You could also have, within the same Kubernetes node, you could have a daemon set, and you check the OPA rules against that. Since it's on the same host, you won't have much network overhead. What generally is not recommended is that you run against other Kubernetes nodes if you're latency sensitive, because then you always have this network round trip for any policy check. So especially if every API request gets validated against OPA, that is a deployment model that won't make much sense. If you just run some checks every hour or so against your Kubernetes cluster, probably this works fine as well. But the general deployment recommendation is to have it co-located and close to the code where it belongs. So why do we at Elastic care about this? We have also included some OPA rules. What that looks like is we have something, we call it Cloud Beat. So I'm not sure if you're familiar with beats, but beats are like the lightweight agents that we have that can run something for you. And we have a new beat called Cloud Beat, and that is one that can run OPA rules for you. So we provide the OPA rules and that Cloud Beat, and it continuously runs those rules for you, and then stores the result, and you can see how they are doing. Right now, you can only use the rules that we have bundled. I hope that in the future you can bring custom rules, because that would be very cool. You could build that yourself with Logstash for now, but CloudBeat doesn't do that yet for you. But what it does is we have a public repository where we have the CSP rules, cloud security posture. Who knows CSP? It's basically a standardization of how things should be configured. So for example, for Kubernetes, there's a standard of these are the things that should be allowed or not allowed in my Kubernetes cluster. And we have basically implemented those as regular rules and run that against a Kubernetes cluster of your choice, and then it will tell you that this is allowed or not allowed. So what that looks like, just to give you a practical example, this is Cloud Posture. This can run against cloud providers, but also against Kubernetes. And again, this is very hard to read. Let me see if I can make it slightly larger. So for example, here I see that against this standard set of rules for my Kubernetes cluster of what is security best practices, and this is based on an open standard of like these rules, 86% of those rules are matching, but a couple of the rules that should be green are not in my cluster. And then I could, for example, look at pod security standards. Let me unfold this to make it slightly larger. And for example, I have Kube API server here. This one I think is a good example. So what this says is, and if the resolution was a bit better, you could read it yourself. It's minimize the admission the container wishes when you share the network namespace. And basically this CIS here, this is the standard of what these rules are in your Kubernetes cluster and what should be allowed. And this basically checks on the Kubernetes API that the host network is not set to true for a specific namespace, because that should not be generally allowed against all namespaces. So it has like the rule, how to fix it, the rationale behind it, and actually the evidence, which tells you that here the host network true is set on the API, and this is not what it should be. And you can then see these are all the rules that are failing in your Kubernetes cluster. So this has, from a set of standard rules, this is what should be in your Kubernetes cluster, has been translated to regular rules. And these regular rules run against your Kubernetes cluster to say what is allowed and what is not allowed. Though, just to avoid confusion, this here is a mix of OPA and then also eBPF. Who knows eBPF? Extended Berkeley Packet Format. So this can figure out something, for example, on the command line, and to see like how are the containers started. So it is not just the API, but also like what is actually running on the systems. So this view is a combination of those two things. But it's basically the regular rules for API things. And then with eBPF, we're checking how things are run on the host by the actual execution on the binary, for example. And this is the combination that you get then to have this cloud security posture that ties then back for your Amazon infrastructure, your Kubernetes cluster, whatever resources you have, you can encode those in here and combine those. Any questions so far? Everyone good? Okay, cool. So to wrap this up, why or why not you want to do that in your application? I hope I kind of like made it clear why you maybe not want to explicitly write all of those rules for security checking in your application. Because A, it's mixed into your regular application logic, so it's very hard to figure out like what is like explicit security checks. It's also very easy to make mistakes there and just make changes as you go along in breaking them. Whereas if you have policies that are external and you can just focus on what the policies allow, it's much harder to miss something. Like you're you change something in your application, it's almost like the test code that shouts somewhere else and says like, this is now broken. So you want to have that separate, ideally. Also, it can be very hard to test an application surface in the application completely. So you probably want to trigger that more from the outside. I've shown you at the very beginning the Ansible example where I was basically checking, I deploy, is the port open, yes or no? But that won't fix it if somebody SSHs into a machine and changes something manually, or if somebody just debugs something quickly and makes a change for that. So what you want to have is not just as you make the change to check for your rules, but also to figure out continuously, my system is in the state where I want it to be, and not just at specific deployments. So you have the assurance that it's always in that right state. And I hope I kind of like gave you an idea of why OPA, and maybe the biggest downside is writing Rego, and I know that we are also struggling to write more complex things sometimes in Rego. I know that the colleagues are sometimes swearing a bit about that as they try to write complicated stuff, but especially for simple stuff like making sure, I don't know, this is where the images are coming from, these labels are applied, these ports are open, a user can only access these resources, this resource needs authentication before you can access it, something is only accessible with TLS. Those are relatively easy to write, but of course you can make it quite complicated with Rego. But the general idea is you have the explicit rules, somebody can audit them, you continuously run them, and then you see in what state are they and how does that tie together. And that's it for Open Policy Agent. Like I said, about 35 minutes. Any questions? Who wants to use OPA in the future or give it a try? Maybe, okay. Try the sandbox, try to adjust those, and then you can quickly figure out how much you love or hate Rego, depending on your JavaScript nature. Any other questions or comments? Yeah, sure.
Hi. When you mentioned the, let's say, different deployment model, there was also one of the complexity I see is like, okay, you have a cluster, maybe you wanted to embed, and those policies need to be probably replicated in some way for all the nodes, for where everything is running. So at the moment, how are you managing that part? So it's like a centralized repository that then it's rolled on all your nodes.
So, I mean, so the things we are doing are not application specific, but only it's like on the like Kubernetes level. So we have avoided that problem, to be honest, because we don't care about it because we only need to run it once centrally as a daemon set against the Kubernetes API, run the tests and are done. I think the deployment model is much more interesting if you tie the requests, or like if you run an OPA policy against specific requests that come in. So, for example, if somebody tries to access credit card information, then you might have an OPA rule to check, like, is this coming from somebody who is allowed to do that? And then you want to have it close by so that you don't add the overhead. So you will need to figure out what is the right deployment model there. But while I think that just deploy it as a sidecar is a nice theory, it's also incredibly expensive if you need to have, like, I don't know how many 100 sidecars rolled out and all over the place. So I feel like this is like a nice idea from the OPA world to do that if you go all in on OPA, but in practice maybe for a few critical services this is what you want, but I don't think you want to have that all over the place.
Yeah, I mean, I have more or less the same impression, but I never tried it. That's why I was asking, because essentially using it for application policy, let's say, you have in theory, you would like, for example, that policy are enforced immediately. Like, I realize that there is a security, and I want to change that, and I want that the second after, let's say, everything is stopped. But of course, if I keep a remote repository with all the rules where all the Rego rules are stored, is going to add a lot of latency. Otherwise, I needed to restart everything or redeploy and provision. So I find quite a lot of complexity that you need to let's say, consider at least.
Right, and I mean, that's kind of like also what we were fighting, where was it? So for example, here, 10 minutes, yeah. We basically, how to actually fetch the Rego rules from S3, bundle them locally into the file system and run them. So basically, that's why we wrote this cloud beat, to actually do that for us. And again, we kind of cheated because we're not running it against an API of the application, but only against centralized services. So deployment is much simpler. But still, since we want to potentially run this for hundreds of customers, we still needed that deployment model. But yeah, there is some plumbing behind the scenes and in the deployment, I think, that is adding more complexity than just Rego itself, because that part looks nice, but the actual production deployment is a bit of a different discussion then. And yeah, I feel like everybody is building their own right now. Like Rego and OPA itself is standardized, but the deployment then, that's pretty customized afterwards. But that's, I guess, how our industry works.
Okay, thanks.
Cool. Everybody else good? Otherwise, thanks a lot. If you want to have some stickers, I brought some stickers and camera covers. I have had some left from a past conference. Since we're security aware, so if you want to hide your camera, take one of these. Take some stickers. Thanks a lot for joining. If you have any questions, I'm here for the rest of the day. Don't be shy, and otherwise enjoy the coffee break. Thank you.